Okay, so good morning, good afternoon, good evening to everyone from wherever you are joining. I welcome you all to the second day of this webinar on space architecture on the behalf of AstroCapsule. And for those who missed the yesterday's session, I'll quickly give you introduction about our speaker, that is Elif Key. So Elif Key is an architect and designer at Earth Architect Studio and supports many companies on many diverse Earth projects. She is a master's student at La Sapienza University in Rome and studies sustainable buildings in space architecture as research project. Elif is founder of OSA, that is Outer Space Architects, and also she supports many STEM-related organizations and societies such as AIAA, IMWS, S4W, and mentoring to some other student groups. One of her main hobbies is traveling. She is a traveler, blogger, and also a camper. Exploring more has expanded her range of exploration, curiosity, and directed her to deep of space. She took many space architecture courses from diverse branches such as space architecture course by SIDI, that is Swiss Institute of Disruptive Innovation School of Disruption, with the partnership of ECACC, that is European Centre for Space Exploration and Colonization, and design exploration towards a moon architecture by MIT Media Lab with the partnership of Polymi, that is Politecnico di Milano, and AIAA courses with partnership of SICSA, that is Saskawa International Center of Space Architecture. She is actively learning about space architecture from her senior mentors and teaching to her junior mentees. She says that she has a natural passion to be one of the architects who lay the foundation of space migration for improving projects in space architecture and specializing in sustainability in orbitary and on Moon, Mars, and beyond. So, without wasting much time, I'll just give you up with today's uh, conditions, and I'll hand over the stage to Elif. All the participants, you cannot unmute yourself, so whatever doubt you have, you can put it in the chat box. I'll be sharing it with Elif. And yes, that's it for today. Elif, you can start with the presentation.
Yeah, thank you so much. I saw a small message on the chat box, someone asking if I was at MIT, but just I took online courses from MIT with the partnership of the Politecnico di Milano. I wanted to make it clear. Yeah, thank you. I'm going to share the screen now. Okay. Um, so this is the second day of our study on the space architecture. I want to shortly summarize yesterday what we did, what we talked about. These are the titles we generally talk about. So first, we made the general space architecture introduction, and then learn about technologies, which makes the space immigration possible. And we are going to continue on that with the technologies which the projects which made for the Mars, and then investigate more about space architecture projects. Uh, we talked about all the details actually about Moon and Mars, the problems and the solutions, and the solution which can be made by space architects as well, and the technologies which will carry us to the Moon and Mars. And I will give more details after this one about Mars. I want to recall about the distance again, because it's the crucial point that we have to realize really how serious is the mission to the Mars, which takes a long journey. And the technology I will talk about, which is made for the Mars, is MOXIE. And for that thing, I firstly want to show a little more about the differences between atmosphere of the Mars and Earth. As you see here, we can see methyl gases which are available on the Mars and Earth, but the percentage is extremely different. As you can see here on the Earth, we already don't have fully oxygen, but the high percentage is nitrogen and oxygen is only 20%. And carbon dioxide on the Earth is among the gases that are trace gases. And also there are a lot of different trace gases included inside of the breath we are taking. When we are looking at to the Mars, the highest percentage is carbon dioxide. So and also there is nitrogen, but the smaller proportion. Argon is very similar to the Earth. So the project of MOXIE is about to convert carbon dioxide percentage to the oxygen. You know about the Perseverance rover that sent to the Mars in 2020 and landed in 2021. And it traveled to the Mars to make investigation of the ground with all the materials and research about the deep of the Earth, to research about the existing ice and water. And also with this rover, there are two important parts. One of it is Ingenuity, which is the first flight of the Mars, and the second one is MOXIE that we will talk about it now. The MOXIE is the one that will work like a tree on the Mars, but here at the first landing to the Mars with the MOXIE and Ingenuity, the MOXIE size is extremely small. Because it's kind of a test of this machine, that if it works, it's not working, how it will. So what is MOXIE actually? MOXIE is a kind of abbreviation of Mars Oxygen ISRO experiment. ISRO is In Situ Research Utilization. So it made with these words, and in dictionary description it says that the ability to face difficulty with spirit and courage. MOXIE is a short, snappy name for a tool that helps lead to human footprint on Mars. It helps humans explore Mars by making oxygen. It works in situ, in place on the red planet, and is an experiment. The project owner is Michel Hacht, and he says that human exploration of Mars will be a seminal event for the next generation, the same way the moon landing mission was for my generation. And also, they are thinking about the benefit of MOXIE, as they think that whenever the first NASA astronauts arrive on Mars, they will likely have MIT to thank for the oxygen they breathe and for the oxygen needed to burn a rocket fuel that will launch them back home to Earth. So as we can see here, MOXIE is not only for producing oxygen for human breath, and also it's very crucial point that will help to rocket fuel to be burned to come back to the Earth, because as you know that the rockets will not be able to be burned without oxygen. When we check on the pieces inside of the Perseverance, the rover, so where is the MOXIE spaced in it? All pieces actually not only designed by one country, but it's a multi-country work, as you can see with the flags here, what they worked on. So also we can see here the MOXIE is in the middle of the rover. And I want to open this detail of the mission and how it works, what kind of parts included in it. What are other duties of MOXIE? MOXIE is the smallest scale actually for now. It will be designed for the biggest. It's designed for the biggest one for the next missions, and it will make more benefit on the Mars. It is ingesting carbon dioxide from the atmosphere and producing propellant-grade oxygen. MOXIE will make 6-10 gram of oxygen per hour, like a smallish tree, or about 50% of what you breathe. And when we are coming into this machine, we have a very important two parts that I will giving the detail about. It's SOXY and screw pump, and it is in the sensor panel. As you can see here, this yellow box is SOXY, which is entire of it. And the pinkish color here is a screw pump that is taking air from outside to inside for changing it. At the exterior view, it is spaced inside with two income for the outcome, and this part is taking the breath, the air inside. However, this screw pump is placed here, and they are placed next to each other. From this chart, maybe it can be easier to understand how it works inside with the chemical descriptions. This is screw pump which is placed next to the SOXY, and it's sucking the air from the outside and taking inside to send to the SOXY. Actual works happens in the SOXY. It works with the same system that we are learning from the chemistry. Actually, it has different two sides, that is cathode and anode, to divide the minus and plus molecules. In this way, it's, as you can see here, there are three pipes which is taking breath, taking air inside and dividing to two with this system, and taking out the oxygen and carbon monoxide and carbon dioxide. Maybe it can be the simplest way how it works. So, but how SOXY is taking in? So there is housing part here and holding this part, and the part that moving and moving screw to take the air inside. The simplest way how the air I mean the carbon dioxide in the air is taken inside for dividing into carbon monoxide and carbon dioxide. And the simplest reaction that is shown here. However, if it works like two, but the benefit is half usually, because of the chemical reaction. When you take the particularly to a carbon dioxide, it will produce half benefit of one oxygen, unfortunately. But with the next project is the same project, but however the size of it extremely different scaled. So the benefit that will be given by the Mars 2020 project will be a kind of demo of the real size of the MOXIE. So with this new scaled MOXIE, that we are going to take more benefit, a kind of small forest than a tree. And then there are some limits of oxygen producing, because it's not possible to use all the energy of the machine to use only for fully oxygen producing. There are also inner pieces capability. So SOXY capability up to 20 gram per hour it can produce oxygen. Power supply capability is also one of the different action inside. And here is it explained about the differences in time, because the machine itself is working differently in the summer nights and the summer mornings, and to the different season or the temperature. And as I said that all the energy which is produced by the machine is not fully used for the producing oxygen. It's losing a lot of power for the machine works, and the highest one is stock heaters, which is taking 72, and electronics conversion. It is 67, and Soxy also is using high, and the pump as well. And I would like to give some example of space architecture project after this. So we are learning how we will go to moon firstly with the Artemis project, and to make it the first, the highest analog area to simulate the life outer space. And then after Artemis 2, we will going to land to the Mars. And what we have to solve is about oxygen to return and to breathe. It was the MOXIE project, and then after we did this, all we have to take our part about design in the habitation. The projects here mostly, actually high potential of the projects are included of 3D printing projects that one of the friends yesterday asked us if 3D printing will be possible. So as seen here, all the projects are actually 3D printing projects except Mars Incubator. Mars Incubator is kind of very similar concept with the Think Orbitals or two projects. They have different part of pieces, and they are combining in the space to each other with this part of connections. I'm going to give details about these all projects. First of all is Mars Ice House. This Mars Ice House, Mars X version 1 and 2 are very important project of search group. And these are first prizes of the NASA's Sentinel Challenge of 3D Print Habitat project. And the question of the friend is written here. So can we design a human habitat on Mars using autonomous 3D printing? Yes, we can. So this is the purpose to do, because human cannot go there without any support, just construct this all needed living area with all the planting. So even the planting should be completed before of humans arrive. As you can see here at the small demo and animation, firstly there will be a descent and landing to the earth, to the ground, and habitat will be deployed. But then, as the shell, exterior shell and the interior shell is ice and ETF translucent material, it should find the H2O, which is water, ice, under the ground. So there is different machines that are working on construction of this building. One of it is very important in this part of finding ice and water underground. I will give details more about these machine robots, how they work, what they do. And finally, after having the source of ice and water, the foundation will be sintering, and ETFE membranes will be inflated. And the second machine, which is important, the robot is important, is printing the shell outer shell and inner shell as well. And then the plant is growing. So if the plants are grow to very well, it shows that the life will be possible here. So a human can be ready to arrive to the place. After the plant's growth, so the crew will arrive. And also, I want to give a last point here. The concept of this project is coming from to take the fresh light outside to inside. So that's why the material is translucent, partially transparent, for free sunlight inside. The machine robotics, which I talked about, are these two very important, Basibo and Aibo. Basibo is the machine that will firstly research about the places which has water and ice, which will be used in this construction of this first habitat. So Aibo is the 3D printing machine that will be used for the exterior and interior, which has a small picture here. Here you can see better here how it works. It's climbing and 3D printing for the interior and exterior, because this project is double shielded. Because of having this double shielded, the exterior part, the yard, is partially protected, but the interior part is extremely protected from all the hazards, radiation, and other else. We can see better detail here how it is. So as you remember that at the small animation, the first land happened here. Some machines, the robotics coming out for research of the ice and water to use it at the IBO, 3D printing of the exterior and the interior shell. Another important point is this part that is airlock. We have to have the airlocks at every project. That is crucial, very significant point that we have to think about. That will protect human from passing outside to inside. The second important project of the search group is Mars X house. Mars X house has two different versions, or version 1 and version 2. First, I want to talk about version 1, and then version 2. This is one of the prize winner of the NASA's. This belongs to phase 3 Habitat Challenge. And in this project, also there are two different parts that are actually connected to each other. And in this project, the concept is about how to take inside the horizon lights, but not the direct lights, because the direct vertical sun rays are very very dangerous for human, and that's why they are making small opening at this part to taking horizontal lights inside. They made this opening with the making two part with two levels. So in this case, they can cover both of them with taking horizontal lights inside. As you can see here, how the two parts connected to each other, and with all needed parts. We are seeing at the plans of the Mars or the Moon projects, there are some small differences from the life on the Earth. They are extremely thinking about how to live in small space and how to make them the larger with the multi-using and flexible usage. And also they care about gym and sport area, and each of houses has its own plant growth part to make a sustainable living. And version 2 is also named Mars X House. It is one of the first prize of NASA Phase 3 again. It is the 3D printing habitat competition in 2018 and 19. And in this project as well, as I said, that before human arrives, all the robotics will construct this building, and with this shape, they're mostly making the concept of to protect from the exterior winds and the forces of outside, because the Mars has the high winds that can damage structure. And yesterday again, one of our friends asked how high we can go. I will explain a little more about this question at the next project. But here also they are trying to make the highest construction. Here, making it curved, as I said, that to make it resistant to the exterior forces, and all the load are included this part. This part is storage of the water, and it's heavy. So you can think of two curved part with the pressure of the high mass on the top that makes the project strong to survive longer. And the nice part here is the openings, which is taking biomimicry from the bee cells of honeycombs. It is the perfect shape, that hexagonal shape is one of the perfect shape that can make biggest surface with the lowest edges. And you can see a small animation how the levels are constructed, what are the steps. So initial of all, after the foundation constructed, so construction parts will be placed, and 3D printing machines will print of the rooms, division and levels. And after seeing about the interior construction, you can see outside details here. As you can see, they have different levels with from the exterior to interior. Regolith concrete is covered exterior, but however, the regolith, the material of the Mars, is toxic material. It's not very healthy for human to have a touch to this ground. It included of toxic material for human skin. That's why they usually cover with the different interior shells. And also for making it strong, the basal fiber is used. So double shelled inside of for protecting human from the toxic regolith concrete. And the base is made of HDPE material. And finally, the window is a piece of assembly and used with hexagon super shape. And Marsha, that is the project as I wanted to talk about. The concept of it is the answer of the question of our friend of yesterday, and why, how we can make it, make the living habitable area higher than the normal concept that is always used to make small domes to protect from the radiation, to go inside the underground. And these were the initial project. However, this new concept is come up to against to this first concept. And this structure, this building has different very important features. This is super strong and has shield radiation. It's also double shielded, double coverage. In any case, we have to protect human itself from the toxic regolith of the Mars. And it is renewable and as seen here, no toxic is included. Yeah, and we can see some design and planning details here, some renderings. And Mars Incubator, one of the extremely different project than the previous one. All the 3D printed habitats, these are extremely different than the others. As I said, that they are combining to each other in this space by its these corner connections. So it's included a lot of hexagons and pentagons. So some of these are opening for lights inside with a transparent material. And last project will be about the project of Hassel Studio. It's EOC. And it includes of two parts actually in the construction. 3D printing for the exterior, and the inside will be inflatable parts. This is the exterior shell with the 3D printing. And so with this part, even if there is no connection than this, so it can make completely protected from the exterior regolith. So this part is the inflatable part. It has all connection from each other and design it for the all needed part. And how it can be inflatable with and connected from this part and inflated inside of under the underground under the regolith part. In this part, we can see that all the pieces are serving for different needs. As I said, that at all the habitats, we have to have research area and green part to produce our food by ourselves to making sustainable life. They are included different parts like workshop. Maybe that will be very useful for in the future long stays. I can mention it in this part, the medical part, greenhouse, laboratory, and living area is very important and crucial points that we have to space at all the projects. And also all the systems should work eco-friendly and sustainable, so it producing its own energy from the sun at the sun using sun. And that was the last. Thank you for listening. I think I finished early today. If you have any question, you can write to the chat box or open your voice to talk, or if you have any addition to all the presentation. I hope you liked it. Lastly, I want to
Great
give my
presentation again.
yeah.
So before starting with the questions, I request all to just fill the feedback form. Yash will be posting it right now. And there are already some questions we have got, so I'll continue with the questions itself. So Aditya Ghosh is asking why dome structure is always considered or preferred for building the base on moon. This was answered yesterday, but yes, again.
A second, I want to stop presenting. That was better, I think. A second. Yeah, okay. Can you tell me the question again?
Why dome structure is always considered or preferred for building base on moon or Mars?
Yeah. Yeah, as I said yesterday. Okay, but honestly, the dome is not only the solution, but the dome is one of the strongest structure shape actually, as the Mars and Moon atmospheric situation is completely different than the Earth. So it has like exterior damages like meteoric crashes, very important actually, especially on the moon. So that is the reason that is used, but still There are other options as you saw on the projects. They're trying to make higher buildings how to solve and different shapes again. Yeah, that's the reason.
Okay, next we have Sebastian again asking, isn't the high winds a problem for the elevators themselves?
Hmm. For the elevators, I'm not sure actually if it affects the elevators because it usually, um, if you talk about the elevators for human using inside of the construction, it will not be affected. But if you're talking about the in the time of when the building constructed, and there will be elevators for 3D printing machines and other robotics to construct the building, that perhaps will effect on the performance of the robot itself. Even the winds carrying a lot of dust, a lot of soil, it can come inside of the robotics and damage it. Maybe it suddenly will stop working, so there will be support of new launches from Earth to the Mars to support new and better improved robotics. There will perhaps damage on that.
Yeah, he was asking about the elevators for that robots itself.
Mm.
Next we have Emmanuel. He's asking, when do they start building on Mars to check if everything is okay?
Hmm. Oh, well, I'm not sure about that, but it will take time for that because we are still at the time to think, to research how to survive. Like, we are really able to go, and if that's time to come, and that first human landing to the Mars. So I think that the time he's asking is very far. Perhaps we'll not able to see that. Yeah.
Okay, next there is I think a feedback from Lokesh. I'll just get on feedback later. We'll get on questions first. We have Alejandro asking a question. What do you think about NASA's call for papers on space elevators from Earth to Moon? And
Uh-huh.
do you think we could have an elevator that would take us to space?
Yes, there is this concept as GEO orbits. As when we were talking about Earth orbits, we talked about one of the orbit which is moving with the same speed of the Earth. Usually, the last point of the elevator will connect to that point to make it less damaged to move with the Earth. Uh, from the Earth to to the Moon, I'm not. What I think is that to firstly connect the last point to the fixed point, which is the GEO Earth orbit, and then that will help economically. This project mostly thought to support economy in the space industry, because even if you carry a small piece of need to the space, it takes a lot of dollars, very expensive to carry that. But if you have like some station of the space elevators, it will the construction of it can be very difficult or very expensive, but still it will for the next features it will support space industry's economy to carry anything to the space, because human thinking to go further and live further. So this will be kind of a highway to space.
Actually, Lokesh had a question. I just skipped it. Lokesh is asking for some images or books or articles you can suggest for them to continue with space
I,
architecture.
yes, yes, I can. I advise you to check uh, Sasakawa International Space Architecture School. On the website, there are a lot of sources. I almost finished all of them. And all the students making their thesis, research, and projects, they all of them like posting on the website. And also, like Professor Banova has a lot of research on the website. You can read freely. This is one of the most important one. And secondly, you can check for AIAA's resources. And I also am one of the volunteer reporter at the AIAA. At every space architectural event, I do check all the speeches and talks, what they talk about, and making reports for the newsletters of monthly newsletters of AIAA. And you can see my research there as well if you want to read. And I can also talk about spacearchitects.org. It is very, very crucial if you want to be space architect. You have to check on that. And last two things I can say. One of it is ISRU. You have to know about the rules, all the text about the ISRU. You can find, just Google it, you can find it. And lastly, I love the works and research of Nexus Aurora. Maybe you have heard about it. They have a big community. You can join that community. Sometimes they post some projects and they look for some partners. They look for someone to support them in design or something else. You can just join their Discord group. How the Discord account is another computer. Maybe I could share with you, but I forgot how to. Maybe I can find it and send to you, Prasad.
Yeah,
So
I'll share it
maybe
later.
share. So the Nexus community is very nice. There are over thousand students there actually, and workers as well. These are I can advise you to do and be active. That's the point. Yeah.
And next we have Charmisha asking for other schools like SICSA where they can go for further space studies.
Mm. For the schools, I also applied for most of them. Like, if you can catch enough scholarship, you just go. Don't wait. As First of all is SIXA, Sasakawa International Space Architecture School, but kind of expensive. But still, you can find a way maybe for like assistantship or scholarship for that. It is the only place for space architecture master program actually, but still, if you want to try general space studies, I think ISU is one of the nice school for learning space with a lot of the disciplinary and they are providing very nice scholarship as well. And if you really don't have enough time for like taking 1 or 2 year for master, you can take short programs. These are SSP, ISP, SHSP, like a lot of different diverse of programs. These are also very heavy and teaching a lot in a short period of time. Some of them taking 2 weeks, 1 month, like over 3 months, like that. So if you check out ISU's website, they also have some resources for reading and learning as well. And lastly, I
Uh,
can do this. If you are not able to join the schools, you can do like me. I got fuller scholarship for the university, so I continue my education still in the space architecture as my thesis research. It is very good chance, I think, but still, it's not. It doesn't mean that you are uh, away from the space sector because my all the mentors from all the space architecture, space sector, so they're supporting my research as well. So not only school, but also the people out of the school can support you in this field. Don't forget that. Yeah.
okay, Abhishek wants to know if there are any internship opportunities available in this field.
Mm, yes, there are. Always see about post of Saga Space Architects, and also I see post of Hassel Studio. They all the time looking for the space architects. perhaps they can accept interns as well. Every year, Saga Space Architects taking one to space architects internees, and I think that will be very nice to post to check the post and email all of the people in the space architecture. The community is not very crowded. You can reach all of them very simple, very easy. And I believe that they are very interested in new people who are wanted to continue their career in the space and space architecture.
Okay, I think Rajpal Singh wants to talk something. Raj, you can unmute yourself.
Yeah, I just wanted to know that can you just type it in the chat box, whatever the different papers or something you said, which is available on the net, which we can refer about space architecture.
I couldn't
Okay.
understand.
Rajpalji will be adding this whole workshop on YouTube very soon. It would be great if you just go on to that. And also, I'll just take everything from Elif, everything possible, and share to everyone who has filled the feedback form.
Yeah,
Okay. And can we have the any email ID or something of Elif so that we can so
yeah,
know
of
more
course.
about space architecture and things?
Yeah. I'm very active on LinkedIn. You can find me with my name and surname Elif Keve, not Kiwi. Just type this name and surname to the LinkedIn. You can find me very easy, and my email is also there. I couldn't text it, I think. Elif Keve, very simple name and surname. You can find me on LinkedIn. I'm very active there. Like WhatsApp.
Okay, for those who have missed, I am sharing the feedback form again. You can
Yeah.
just fill it. And yeah, that's it. I don't think there any other questions. If there are, so we'll be waiting for 2 minutes. You can just put your questions in chat box, or else we can end with the session.
Today I didn't ask a lot of questions to them. Just wanted to make sense. But still, really very important to say this. If you really want to continue with the space architecture project to be a partly space engineer, being only the designer and the art maker is not enough for space. Very important to know knowledge and how to combine it with the art. This is the space architecture.
So yeah, I don't think there are any other questions. So we can just end with today's session. Thank you all
Yeah,
for joining for the workshop. Thank you, Elif, for this wonderful presentation.
yeah. Hope you liked
And
it.
yeah, I loved it. And hope to see you guys in the upcoming events too. We'll be planning more events on space architecture. We'll be planning for different competitions, webinars, and many more stuff. We'll, I hope to see you all guys there also. And yeah, again, thank you so much for joining.
Yeah, thank you so much. Take care all.